Now, this is quite a story from NASA because for the second time in history, a man-made object has left our solar system. NASA is saying the Voyager 2 probe is now in a space between the stars after exiting the sun's protective bubble, which is called the heliosphere.
In the vast, indifferent sea of stars, where the distances between objects are not measured in miles or kilometers, but in the ghostly stretch of light years, where galaxies drift like ancient ships and the silence presses down like eternity, there exists a lonely traveler. A traveler unlike any other. Forged by human hands in the twilight of the 20th century, this fragile construct of metal, wire, and will has defied everything: the decay of time, the limitations of its design, and even the predictions of the scientists who built it. It was never meant to endure this long. It was never expected to reach this far. And yet, it moves still. Its nuclear heart, once full of promise, now pulses faintly in the cold, its warmth slowly bleeding into the void. Its voice, barely a whisper, rises across unimaginable distances, fighting entropy and silence with every bit of data it sends home. It is old, it is tired, it is fading, but it still speaks, and what it says has astonished the world. NASA has just confirmed what would have been considered unthinkable a few decades ago. Voyager 2, launched in 1977 during the infancy of space exploration, has crossed a cosmic threshold and entered into interstellar space. It is only the second human-made object in history to leave the heliosphere, the sun's protective magnetic bubble, and pierce the unknown realm between stars. Yet what makes this moment so profound is not merely the milestone of distance, but the discovery of what lies on the other side. What Voyager 2 has found is not emptiness, but mystery. Not silence, but structure. Not the end, but the beginning of something far stranger than anyone had imagined. The spacecraft, now adrift more than 12 billion miles from Earth, a distance so vast that its signals take over 18 hours to reach us, has crossed the heliopause. This boundary, once believed to be a diffuse and passive region where the solar wind gradually dies into the galactic background, has been revealed to be something far more dynamic. It is not a soft, evaporating edge, but a sharply defined zone of transition, a place of change, a place of revelation. And in passing through it, Voyager 2 has peeled back a layer of the cosmic veil. Scientists once described the heliopause as a kind of borderland, a buffer between solar and interstellar domains, a blurry, cloud-like region of turbulence and dying solar influence. But Voyager 2's instruments have recorded something far more intricate and volatile. What it found was not a curtain fading into space, but a membrane teeming with electromagnetic force, with pressure, with sudden shifts in plasma density and magnetic alignment. It wasn't a transition, it was a rupture. The probe's sensors, built with 1970S technology and never intended to operate this far from home, began to relay readings that no model had anticipated. The magnetic field, instead of dissipating, intensified dramatically by a factor of 3, and it did not surge randomly. It was ordered, aligned, coherent, a vast and structured magnetic field far more precise and directional than the turbulent pattern science had predicted. Even more bewildering, this pattern bore no resemblance to what Voyager 1 experienced when it crossed into interstellar space years earlier. The contrast between the two suggests that the edge of our solar system is not a fixed boundary, but a patchwork of distinct regions, each with its own magnetic signature, each shaped by unseen galactic forces. But it wasn't just the magnetism that caught scientists off guard. It was the behavior of the cosmic rays. These are high-energy particles that sweep through the galaxy at near-light speeds, remnants of distant cataclysms, supernovae, black holes, violent collisions that occurred long before Earth had oceans. According to existing theory, once Voyager 2 passed into interstellar space, these rays should have appeared as a relatively uniform background, evenly distributed across the probe's sensors. Instead, they surged and ebbed in strange pulsing rhythms. They arrived not from every direction, but from specific skewed angles, as though being funneled or redirected by invisible structures. Like wind funneled through a canyon, the cosmic rays bent and curved as if guided by immense magnetic filaments or gravitational anomalies lurking in the galactic dark. The spacecraft, in effect, was swimming through rivers of high-energy particles, currents that no one knew existed. And then there was the plasma, the hot, ionized gas that makes up much of the known universe. It was expected to be thin, sparse, and weak in the void beyond the heliopause. Yet, what Voyager 2 found was something denser, colder, and altogether unfamiliar. It was neither solar plasma nor interstellar plasma. It was something transitional, a liminal substance, a form of matter that did not behave according to any known model. It flowed differently, it reacted differently. It was shaped, seemingly, by boundaries and forces we have not yet discovered. Rather than a fading breath of solar wind, the plasma Voyager 2 encountered seemed to occupy a state of suspension, structured, slowed, compressed, as if it were caught in an invisible sheath around the solar system, pressed between the outgoing currents of the sun and the incoming tides of the galaxy. This zone, this buffer, had never been observed, never predicted, and may represent an entirely new category of physical reality. Its implications are enormous. The transition zone may act as a cosmic filter, a shield, or even a transformative region, where solar material is reprocessed into interstellar matter. It could be a kind of galactic gateway, not just in distance, but in phase. If so, it challenges our very definitions of where the solar system ends and the galaxy begins. The boundary may not be a border, it may be an ecosystem. And Voyager 2, silent and steady, is mapping it for us in real time. These discoveries suggest that the edge of the solar system is not an edge at all. It is not a crisp border separating the known from the unknown, but rather a complex, reactive, and dynamic zone, more like a living membrane than a fixed shell. Like the shifting boundary between atmosphere and ocean, it ebbs and flows with forces from within and beyond. What Voyager 2 has revealed is that this boundary is not passive. It breathes, pulses, reacts. It is not the edge of a bubble, but the surface tension of a cosmic tide. The long-standing notion of the solar system as an isolated oasis, drifting peacefully through a neutral, passive interstellar void, has now collapsed. Instead, what emerges is the image of our solar system as something deeply entangled, wrapped in invisible threads that bind it to the larger structure of the Milky Way itself. It floats not in emptiness, but in an evolving sea of galactic currents, magnetic scaffolding, and perhaps even concentrations of dark matter that warp and twist the space around us in ways we have only begun to measure. One of the more immediate puzzles arose from the distortions in Voyager 2's radio transmissions. As its faint signal traveled back across the yawning abyss of space to reach Earth, it began to exhibit subtle but persistent modulations. Frequency shifts, echo delays, and irregular phase patterns that could not be explained by equipment faults or solar interference. These distortions suggested that the radio waves were being refracted, bent, and scattered by unseen obstacles or fluctuations, features in the interstellar medium that had, until now, eluded detection. The implications were profound. They pointed towards structures, density waves, folds in plasma, even standing wave formations on astronomical scales, that defied every notion of deep space as a uniform void. Like ripples frozen into the fabric of space itself, these phenomena suggest a textured, resonant environment, more akin to an ocean with currents and layers than a vacuum. Voyager 2 was not transmitting through emptiness, it was whispering through a storm. Then came the unexpected magnetic reconnection events, violent realignments of magnetic field lines that unleashed vast amounts of energy in the span of seconds. These are phenomena normally associated with active solar regions or the violent throats of neutron stars, not the cold, supposedly tranquil realm of interstellar space. And yet Voyager 2 detected them far from any stellar body. Sudden reversals in magnetic polarity, energy surges, bursts of particle acceleration. The inference was staggering. The heliopause is not a place of quiet retreat, but a zone of active energy transformation. Here, the sun's magnetic field, long thought to slowly wither into nothingness, instead snaps, twists, and possibly merges with the powerful forces of the galactic field beyond. It is not just a boundary, it is a crucible, a collision zone, a handshake, perhaps, between solar identity and galactic inheritance. But the surprises didn't stop with magnetic anomalies. Voyager 2's sensors also recorded something more intimate: temperature shifts, sharp, localized jumps and drops that occurred over distances of just a few kilometers. These were not gradual transitions expected from drifting into a colder or warmer region. They were sudden, abrupt, and inconsistent. Like microclimates or thermal fronts on Earth, they hinted at the presence of hidden boundaries, shock fronts, eddies, pressure ridges, woven throughout the plasma. These fine-grained thermal changes suggest a new and perhaps unexpected conclusion. Interstellar space has weather. Not clouds or rain or wind in the terrestrial sense, but turbulent pockets, shifting densities, and thermodynamic instabilities that mirror on a much larger and subtler scale the complexity of atmospheric systems on Earth. As more data poured in, a picture began to emerge, one that was far more structured, organized, and strange than anyone had dared to imagine. The consistency and coherence of the observed plasma waves could no longer be dismissed as random turbulence. These waves formed stable, patterned oscillations that extended across time and space, vibrating at frequencies that echoed like tones from a giant cosmic instrument. When translated into audible frequencies, these plasma waves became deep, resonant hums, otherworldly sounds that seemed less like noise and more like language. Some researchers have begun calling them plasma quakes, likening them to seismic waves, ripples not through rock but through the very medium of interstellar space. If this analogy holds true, then the space beyond the solar system is not a vacuum at all. It is a medium that resonates, that vibrates, that sings. The philosophical implications of this are staggering. What does it truly mean to leave the solar system if the boundary is not a line but a transformation? If the heliopause is not fixed but fluid, sculpted by galactic pressure, stellar winds, and invisible architecture, then our concept of inside and outside breaks down. The very idea of the solar system as an isolated sphere becomes outdated. Instead, what Voyager 2 reveals is that our solar system is not an island. It is a tributary, a stream flowing into the vast ocean of the galaxy. Space, it turns out, is not partitioned into clear zones but layered in gradients of influence, energy, and complexity. The line between what belongs to us and what belongs to the galaxy dissolves, and with it, the illusion that we are somehow separate from the forces that govern the stars. This realization has prompted renewed urgency in one of the most sobering questions of modern astrophysics. How vulnerable is Earth to the changes that occur at this galactic threshold? If the heliopause acts as a kind of magnetic shield, dampening or deflecting cosmic radiation, then any change in its configuration could have consequences for Earth. As the solar system moves through the galaxy, encountering new interstellar environments, fields, and clouds of material, it's possible that the shape and density of this shield fluctuates, exposing our planet to varying intensities of cosmic radiation. Some now believe that major geological shifts, climate change events, sudden bursts of mutation, even mass extinctions, could be tied to these galactic weather patterns. If so, then Voyager 2 is not just exploring the far edge of space. It may be uncovering a hidden story about Earth itself, a story we've never been able to read until now. Even more provocative are the suggestions emerging from the most daring corners of theoretical physics. Some scientists propose that the plasma Voyager 2 is moving through may represent a new state of matter, a kind of exotic plasma that does not obey the familiar rules. It does not behave like solar plasma, nor like interstellar plasma. It appears to organize itself without an obvious source of order, responding to magnetic and electric fields with a strange kind of intelligence. It flows with resistance, yet carries structured waves. It's not random. It's not chaotic. It's something else. Something that might point to laws of physics we haven't yet written down. And then, whispered quietly in scientific halls and speculative conferences, there's a possibility even more controversial, one that teeters on the edge of science fiction. Could some of what Voyager 2 is observing be artificial? Could the coherence of these fields, the stability of the waveforms, and the symmetrical structure of these magnetic zones be the product of design, not necessarily of civilizations as we understand them, not cities or ships, but perhaps of long-dead astrophysical engineering, vast and ancient and beyond our comprehension, remnants of galactic-scale processes that were once deliberate, machines, perhaps, or mechanisms embedded in the very layout of space, now asleep and eroding into the background radiation of the universe. It is speculative, yes, but the fact that such possibilities must now be considered is a testament to just how deeply Voyager 2 has disrupted our understanding. In the end, what this tiny spacecraft has uncovered is not just a new chapter in astronomy. It is an entirely new volume, one filled with pages we did not know existed, written in a language we are just beginning to translate. And the further it travels, the more it teaches us that the frontier of knowledge is not found in the places we have charted, but in the spaces where our certainty runs out. Voyager 2, sailing deeper into the abyss, continues to remind us that in the silence between the stars, there is more than emptiness. There is architecture, there is energy, there is story, and above all, there is wonder. As the spacecraft drifts further into the unknown, its instruments continue to function with eerie reliability. Every pulse of information it sends back is a whisper from a place beyond imagination. The data is cryptic, sometimes contradictory, but always revelatory. Voyager 2 has become something more than a probe. It is now a philosopher of the stars, a blind sentinel navigating by touch alone through a realm that defies logic, beckoning us to rethink everything we thought we understood about space, time, matter, and ourselves. Its journey, once designed to last 5 years, is now approaching its 50th. Its golden record, etched with greetings from Earth, music, and messages of peace, still spins quietly in the void, an echo of humanity drifting through the darkness. And yet, it is not silence that Voyager 2 finds, but a symphony, a complex and haunting harmony of plasma, magnetism, radiation, and structure that challenges the very syntax of science. And so, across the endless night, the signal continues. We listen, we translate, and we marvel. What Voyager 2 reveals may not always make sense, but it always matters. In its quiet endurance, in its defiant persistence, we are reminded that exploration is not about arriving, it is about asking better questions. And sometimes it takes a machine launched in the age of disco, designed with slide rules and soldering irons to whisper the greatest truths about the cosmos. Voyager 2 is not just a machine, it is an idea made real, a statement that knowledge is always possible, that even in the cold and silence there is music. As long as it lives, as long as its voice reaches us, we will know that there are still frontiers left to cross, mysteries left to embrace, and distances left to dream. Still it drifts, still it speaks, and still the universe listens. Voyager 2's journey is not merely a scientific expedition, it is the embodiment of a human spirit that refuses to be confined by its own limitations. It is a fragile machine, a product of slide rules and soldering irons, born in an era of Cold War tensions and analog signals. Yet it continues to whisper across the stars with a voice more powerful than ever. Its signals are not just data, they are testaments to our collective need to explore, to question, to reach beyond what is safe, and to ask not just how, but why. This ancient spacecraft, launched in 1977, was designed for a mission of only 5 years. It has now exceeded every expectation by decades, slipping quietly into the cold unknown, defying gravity, time, and the boundaries of knowledge. And in doing so, it has rewritten what we believed about the solar system's edge. Voyager 2 did not merely cross a line, it crossed a threshold that no human technology had ever touched before. And what it found beyond that threshold is reshaping the very foundation of space science. We once thought of the heliopause, the edge of the solar system, as a vague and quiet boundary, a gentle fading of the sun's influence. Voyager 2 has shown us it is anything but gentle. It is not a curtain. It is a membrane alive with magnetic tension and plasma turbulence. It is not a wall, it is a veil of forces dancing in resonance. And this membrane is not the end, it is the beginning of another world, another set of rules, another chapter in the great cosmic narrative. It is proof that even our best models are not maps, but sketches drawn on incomplete knowledge. What Voyager 2 has revealed is that the unknown is not a void, it is a symphony, a humming, pulsing, reactive sea of plasma waves, particle fields, and electromagnetic structures that stretch and curl across light years. The probe's instruments, old, delicate, and limited by today's standards, have sensed things no theory predicted. Magnetic fields that should have weakened instead strengthened, plasma that should have thinned instead condensed, radiation that should have diffused instead focused. These are not anomalies, these are revelations. These revelations teach us that the universe is not static or simple. It is layered, it is textured, it is alive in ways that challenge every assumption we once held about the silence beyond our sun. The cosmos is not sterile or dead. It is a breathing cathedral of forces and interactions, still humming with the echoes of its own creation. And it is only now, through Voyager 2's persistence, that we are beginning to hear its deeper harmonies. The philosophical implications of this are vast. Voyager 2 does not just teach us about plasma or radiation or magnetism. It teaches us about humility. For decades, we believed we had charted the shape of our solar system, drawn its borders, named its limits. But Voyager reminds us that every line we draw in the universe is provisional. Every certainty is a placeholder for a better question. Science is not a finished text, it is a living dialogue with the unknown, and Voyager 2 is one of the purest voices in that conversation. And yet there is something deeply personal in this journey. Voyager 2 is not just a machine drifting through vacuum. It is a vessel carrying human fingerprints, human dreams, and human echoes. It bears a golden record etched with languages, music, greetings, and memories, an offering from Earth to whatever may one day find it. In this, Voyager becomes not just a scientific instrument, but a kind of ark, a message in a cosmic bottle, declaring to the universe, we were here, and we wondered. That sense of wonder is perhaps Voyager 2's greatest gift. It reminds us that exploration is not about conquest or control, it is about communion, about reaching into the dark, not to master it, but to participate in it. Voyager 2 asks nothing of the stars. It does not conquer, it does not extract, it listens, it records, it reflects, and in doing so, it transforms both the cosmos and ourselves. There is a lesson here about endurance. Voyager 2 was not flashy or fast, it was not powered by vast budgets or cutting-edge AI. It was simple, elegant, and slow. It moved with patience. And in that patience, it outlasted doubt. It outlasted war. It outlasted the boundaries of its own design. It teaches us that great things do not always need great noise. Sometimes the most important truths arrive not in explosions, but in whispers. Its findings on wave-particle interactions, plasma compression, interstellar turbulence, and directional cosmic rays are not just scientific curiosities. They are tectonic shifts in how we understand the universe. The data speaks of forces we cannot yet explain, of boundaries that behave more like membranes than barriers, of space that sings in frequencies we are only beginning to hear. And in that music is a message, not just about physics, but about ourselves. Because what Voyager 2 also teaches us is that we are not observers of the cosmos, we are participants. Our planet is not an island isolated by vacuum, it is embedded in the rhythms of the galaxy. It is shaped by magnetic tides and cosmic winds, by the long breath of interstellar drift, and if we are shaped by those forces, then so is our history, our biology, our climate, perhaps even our consciousness. We are not just in the universe, we are of it. And so as Voyager 2 continues on its path, slower now, quieter perhaps, but still alive, we are faced with a responsibility to listen, to learn, to reimagine. Because every signal it sends is not just data, it is a challenge to think bigger, to see deeper, to wonder harder, and above all, to remember that the greatest edge we can cross is not the one between planets or stars, but the one between ignorance and understanding. Voyager 2's persistence tells us something crucial about time, that meaning is not always immediate, that some truths are only visible after decades of waiting, that sometimes the clearest voices come from the most distant places, and that endurance, quiet, unseen, and faithful, is as powerful as discovery. And perhaps this is why its journey touches us so deeply, because Voyager 2 reflects the journey of humanity itself. We are also travelers, we are also seekers. We launch our questions into the darkness, hoping for a reply. We build fragile vessels of language, of memory, of technology, and send them into the unknown. We hope they will outlast us. We hope they will be heard. As the light from our sun fades behind it, Voyager 2 becomes less a spacecraft and more a storyteller, a narrator from the frontier, a chronicler of a borderland we never thought we'd reach. It tells us that the universe is bigger than we dreamed, that our models are smaller than the truth, and that our thirst to know is the fire that drives us forward, no matter how cold the stars become. So let us not forget what this little machine has done. Let us not let its signals fade unnoticed. Let us carry its story as part of our own. Because Voyager 2 did not just break through the boundary of the solar system, it broke through the boundary of what we thought we could do. And in doing so, it left a trail of light in the dark for others to follow. In the end, Voyager 2 teaches us this: the edge of everything is not the place where answers stop. It is the place where the best questions begin. And in asking them, we do not diminish the mystery of the universe. We become part of it. Still, it drifts. Still, it speaks. Still, we listen. And in that listening, we become something more than we were.